Good morning, students. Now, once again, in continuation with applications of derivative. Now, once again, applications of derivative point of view, we have to just consider the descriptive problems related with tangent and normal to the curve. So, first one question, it is descriptive. Find the point on the curve y equals to square root of x minus 3, where the tangent is perpendicular to the line 6x plus 3y equals to 5. So meaning of that, tangent is perpendicular to this line. This line means as far as that slopes are concerned, slopes are negative reciprocals of each other. So if we consider that line is tangent, then definitely that slopes point of view, just we have to think about that. So first of all, given equation of that curve, it is y equals to square root of x minus 3. So we have to differentiate with respect to x. So for that, we have to just consider squaring both sides. So y square equals to x minus 3. Now differentiate with respect to x. So derivative of y square, it is 2y into dy by dx equals to, now derivative of x, it is 1, and derivative of 3 constant point of view 0 equals to 1. So dy by dx, it is modified form 1 upon 2y. Transfer that 2y towards the right hand side, which is the slope of tangent to the curve. Now again we have to just think about the equation of that line 6x plus 3y minus 5 equals to 0. Now we can calculate slope of that line first. M equals to, now formula to calculate the slope of line. It is in general, for the general form of that line, minus coefficient of x divided by coefficient of y. Look into the coefficient of x, it is 6. So it is minus 6 divided by coefficient of y, it is 3. So it is divided by 3 equals to minus 2. So slope of that line M equals to minus 2. Now condition point of view, but tangent to the curve is perpendicular to the line first. So perpendicular point of view, slope of tangent equals to, you can write minus 1 upon slope of that line first, because lines are perpendicular, then slopes are negative reciprocals of each other. So dy by dx equals to minus 1 upon that minus 2. Slope of that line, it is m equals to minus 2. So you can put that value, minus minus becomes plus. So value equals to 1 by 2. So finally, that slope of tangent, it is nothing but 1 by 2. So therefore, slope of tangent, it is 1 upon 2y equals to 1 by 2. Now that 1 by 2 and 1 by 2 get cancelled. So y equals to 1. Now again, we have to calculate the coordinates of that point on the curve. So for that, y equals to, given value, square root of that x minus 3. So put the value of y, it is square root of x minus 3. So squaring both sides point of view, 1 square, it is 1. So x minus 3. So x equals to, if we transfer that minus 3 to the left, so 1 plus 3. So 1 plus 3 means you can say equals to 4. So the point on the curve is p into bracket x1 y1 in general, and it is 4 comma 1. Now second example, look into that properly. Find the equations of tangents to the curve x square plus y square minus 2x minus 4y plus 1 equals to 0, which is parallel to the x-axis. So as far as that tangents are concerned, those are parallel to x-axis. Now any one line, if suppose parallel to that x-axis, so as far as that line is concerned, suppose that x-axis and y-axis point of view, if we consider, suppose this is x-axis and y-axis, and it is parallel to x-axis. So if we line this one, it is parallel to x-axis, then it is perpendicular to definitely that y-axis. So if any one line is parallel to x-axis, means angle between these two, it is 0. So therefore, theta equals to 0. Theta equals to 0 means tan of theta equals to 0. So tan of theta equals to 0 means slope of that line it is 0. That means dy by dx equals to 0. So for that, if we consider, then first of all, given equation of that curve, it is in the form x square plus y square minus 2x minus 4y plus 1 equals to 0. You call it is the implicit function. So differentiate with respect to x. So 2x plus 2y into dy by dx minus 2 into 1, derivative of x with respect to x, it is 1, minus 4 into dy by dx plus 1, it is there, but derivative of that plus 1, that means constant, it is 0. So equals to 0. So modification, the terms of dy by dx, this is 2y and this one it is minus 4. So 2y minus 4 into dy by dx equals to, transfer that 2x to the right hand side, so it is minus 2x, and this minus 2, it becomes plus 2. So finally 2, as we consider common, then y minus 2 into dy by dx equals to minus x plus 1. So just dy by dx equals to minus x plus 1. Transfer that y plus 2 towards the right hand side. So it becomes minus x plus 1 divided by y minus 2, which is the slope of tangent to the curve. But tangent to the curve is parallel to x-axis, as we have already discussed. So definitely slope of that tangent, it is equals to 0. Slope of tangent equals to 0 means you can say dy by dx equals to 0. You know the value of dy by dx, minus x plus 1 divided by y minus 2 equals to 0. Transfer this y minus 2 to the right hand side. So 0 into anything equals to 0. So therefore x minus x plus 1 equals to 0. That means minus x equals to minus 1. So x equals to 1. So just put that value for that y. Means for y, put x equals to 1 in the equation of that curve. So what is the equation of that curve? You know. So 1 square plus y square minus 2 into 1 minus 4y plus 1 equals to 0. So 1 plus y square minus 2 minus 4y plus 1 equals to 0. So that minus 2 and this plus 1 becomes 2. Plus minus 2 get cancelled. So what remain? Y square minus 4y equals to 0. So y it is common. So y minus 4 equals to 0. Each bracket equals to 0 means y equals to 0 and y minus 4 equals to 0. Now y minus 4 equals to 0 means you can say y equals to 4. So the points on the curve are 1, 0, or you can say 1, 4. So at this point we have to calculate the slope of tangent. So for first type, slope of tangent at point 1, 0 is, if we put that value, minus 1 plus 0, 0 minus 2. So it becomes 0 upon minus 2. You know 0 upon anything equals to 0. So by using slope point form, we can calculate the equation of that tangent is. You know equation point of view, it is slope point form, y minus y1 equals to m into bracket x minus. So y minus 0 equals to 0 into bracket x minus 1. So 0 into anything equals to 0. So finally it is y equals to 0 is the first equation of that tangent. So again for next one point we have to calculate the slope. So slope of tangent at point 1, 4 is dy by dx equals to minus 1 plus 1 divided by 4 minus 2. But at last plus 1 minus 1 0. So 0 upon anything equals to 0. So again by slope point form, equation of tangent, it is y minus 4 equals to 0 into x minus 1. But again to the right hand side, 0 into anything equals to 0. So y minus 4 it is 0. So y equals to 4. So therefore the equations of tangents are simply y equals to 0 and y equals to 4, which are definitely parallel to the x-axis. Now the next equation we have to consider, third one problem. If the line y equals to 4x minus 5 touches means you can say it is tangent to the curve y square equals to ax cube plus b at point 2, 3. That point it is given means it is the point common between that curve and that tangent. That means line y equals to 4x minus 5. Then we have to find that a and b. So first of all, given y square equals to ax cube plus b. So line is tangent to the curve means just we have to consider the value of dy by dx at that particular point. So we have to just differentiate equation with respect to x. So 2y derivative of y square into dy by dx equals to a, it is a constant outside the derivative, but derivative of x cube it is 3x square. So it is 3ax square plus b separate constant it is there, so derivative 0. So finally it becomes 3x square. So what is the value of dy by dx with unknowns? 3ax square upon 2y. So slope of tangent at this point 2, 3 is dy by dx at point 2, 3 it is 3a upon 2 multiplied by that 2 square divided by 3. So that 4 as it is, but 3 and 3 get cancelled. So 4a divided by 2. So 4a upon 2 means it is 2a. But now again, as we consider that given equation of that line, it is y equals to 4x minus 5. Transfer that y to the right hand side, it becomes minus y. So that equation becomes 4x minus y minus 5 equals to 0. Equation first. Again, we can calculate the slope of that line first. So m equals to minus coefficient of x upon coefficient of y. You know formula. So minus minus plus. So it becomes 4. But now line first is tangent to the given curve. Tangent means slope it is same. So dy by dx is nothing but m and it is equals to 4. But value of dy by dx you are already calculated. It is twice a. So equals to 4. So a equals to 2 because 4 upon 2 means you can say it is 2. Now again we have to calculate the value of second unknown. So for that point 2, 3 is a point on the curve which is a point of contact. So equation of curve becomes, put the value of that x it is 2 and y it is 3. So 3 square equals to 2 which is the value of a and 2 cube means value of x. So plus b as it is. So 9 equals to 2 multiplied by 2 cube means 8 plus b. So 9 minus 16 equals to b. So finally, what is the value of b? Second constant, it is minus 7. So these types of problems you have to solve for that applications of derivative means descriptive problems. So again solve the problems for a practice. Thank you.